Good day, everyone. We are the Group 3 of St. Thomas of Aquinas, here to present you our video lesson in pre-calculus. The members of our group are yours truly, Gregory Salinas, Denise Carabbacan, Frank Tamayo, Elvilyn Garcia, Llyah Barnal, and Rafael Antonio. This video will discuss the 6 subtopics for the graphs of circular functions and situational problems. The objectives for this video lesson are: define each of the terms on the presentation, define simple harmonic motion. The learners will be able to learn the difference between sine and cosine graph. The learners will be able to learn the difference between secant and cosecant function. The learners will be able to learn the difference between tangent and cotangent function, know how to draw the graph of sine and cosine function, know how to draw the graph of secant and cosecant function, and lastly, know how to draw the graph of tangent and cotangent function. The first topic that we will discuss is the graphs of y equals sin x and y equals cos x. Remember that the sine and cosine functions are used to convert real numbers into the x and y coordinates of a point in the unit circle. So, how do they appear on a graph on a coordinate plane? Begin with the sine function. We can make a table of values and use it to draw a graph. The table below shows several examples of sine function values on a unit circle. To make a table of y equals sin x, we need to identify the points in the unit circle which are 0, pi over 2, pi, 3 pi over 2, and 2 pi. The respective coordinates of those are 1 and 0, 0 and 1, negative 1 and 0, 0 and negative 1, and back to 1 and 0. We need to find the y values in the coordinates which are 0, 1, 0, negative 1, and 0. The table for y equals sin x, we just need to find the points of a unit circle which are 0, pi over 2, pi, 3 pi over 2, and 2 pi. Second, we just need to identify the y value in a unit circle where the sine function only consists of 0, 1, 0, negative 1, and 0. As a result, the table will look like this. In making a graph, you just need to organize the set points which are 0, pi over 2, pi, 3 pi over 2, and 2 pi. For the wave, you just need to map up the y value of the given set points in the table which are 0, 1, 0, negative 1, and 0. To get the table of y equals cosine x, we follow the same steps as with getting the table for y equals sin x. However, we identify the x-coordinate of the points on the unit circle, which results in the coordinates being 1, 0, negative 1, 0, and 1. In making a graph, it is similar to making a graph on the sine function. You just need to organize the set points, which are 0, pi over 2, pi, 3 pi over 2, and 2 pi. For the wave, you just need to map out the x value of the given points in the table, which are 1, 0, negative 1, 0, and 1.
For the next topic, it will be graphs of y equals a sin bx and y equals a cos bx.
First is let us know the different parts and features of a graph. The period. Period is a distance or time between the wavelength to curve on the midline from its origin or the sine and from the y-axis or cosine. As a result, the formula for the period is as follows. Period equals 2 pi over b. Second is the amplitude. Amplitude is a distance of the wavelength from the midline of the graph. It is how high or how low does a wavelength from the x-axis. The y and x-axis, horizontal and vertical, have no shifts at this moment. A vertical shift is the movement of the graph up and down that affects the y value, whereas a horizontal shift is the movement of the graph left and right that affects the x value. That is, if there is no vertical shift, the graph will always start between the origin or sine and or in the y-axis. And if there is no horizontal shift, the graph will start either at the origin or sine and or in the y-axis cosine. Let us now define the difference between the sine and cosine graph, both positive and negative. First is the positive sine. The sine function will always start on the origin 0, 0, even if it is a positive nor negative function. If the function is positive, the shape of the graph will look like the graph on the sine. Since the amplitude is on the positive graph will look like the graph on the side. The wave from the origin goes below the midline, unlike the positive that goes above the graph. For the next part is the cosine function involving positive and negative factors. The positive cosine function will start on the y-axis, which the amplitude is at a positive 10 on the given graph. Even though it is a positive and negative function, the graph will appear like the graph on the side, which is distinctly diverse on the sine graph, since the positive sine graph will go above the midline, whereas the positive cosine graph will go below the midline. Next is the negative function of it. The cosine function is on the negative amplitude on the y-axis. The graph will look like the graph on the side, with the wave utilizing above the midline, unlike the positive cosine function utilizing below the midline. So we already know about the parts and features of the graph, both sine and cosine. Let's now take it into an example. Example number 1. Determine if the graph below is y equals a sine bx or y equals a cos bx, and then create an equation of the form y equals a sine bx or y equals a cos bx. So, in determining the graph, make sure to look where is the origin of the wave located. Since the wave is on the origin of 0, 0, and thus the amplitude of the wave starts above the midline, and this will be concluded that this is a positive sine graph. Next is we must find the amplitude and the value of b, which is the period. So, amplitude is a distance between the center line and the peak of the wave, which the amplitude is positive 1, since the wave starts to curve at the positive amplitude, while on the negative sides, the amplitude is on the negative 1. As we got the value of b, is we must find the value of the period. The period is a distance between the curve of the wave from its origin, and since period can only measure only one or two cycle of the wave, since it is just a repeating wave cycle of the graph, the period will be 1.5 pi. As the formula of the period is period equals 2 pi over b, it will become period equals 2 pi over 1.5 pi is equals to 1.3. As stated, the letter b, which signifies the period or the wavelength of the graph, the period is controlled by b. So since the amplitude is 1 and the period is 1.3, we can now formulate the formula of sine y equals a sine bx. It will become y equals 1 sine 1.3x. So for the next example, let's try to make it on reverse. Graph the given equation of 1 sine 2x. So first is we must find the value of b or the period using the formula of period equals 2 pi over b. So since the value of b is 2 in the given formula, that means period equals 2 pi over 2 is equals to pi, and the amplitude will be on the positive function, since the given value of the amplitude is positive 1 on the given equation. The given equation is in the form of sine function, which means the graph will start on the origin of 0, 0. So since the period is pi and there's only one period, that means there's only one cycle between the origin and the pi, which the wave will take up on the amplitude of positive 1 and negative 1. By this, the graph will only have 4 parts. The end of the cycle, which is pi, the half of the pi, which is pi over 2. This is the end of the first wave from the origin up to the midline. Then halfway between the pi and pi over 2, which is 3 pi over 4. And half of the pi over 2 from the origin, which is pi over 4. As a result, the given equation would be graphed look like this on positive sine function. First example is determine if the graph below is y equals a sine bx or y equals a cos bx, and equate an equation of the form y equals a sine bx or y equals a cos bx. Next example is we see that the origin of the wave is on the y-axis or in the amplitude of positive 10. So this graph is a positive cosine function. Next is we must find also the amplitude and the period. The amplitude is on how high the graph or how low the graph is from the midline. So as the graph we see above, the graph was on the positive amplitude of 10. So our amplitude on this graph is positive 10. Now we must find the period of the cosine graph. As the definition of the period is the distance between the origin of the wave to the end, so which means the period is 2 pi. Next is we must use the formula of the period, which is period equals 2 pi over b is to 2 pi over 2 pi is equals to 1 pi or 1. So the result of the equation is will be y equals a cos bx equals to y equals 10 cos 1x. Let's try to make it in reverse so we can also check if the equation above is right. Graph the given cosine function of y equals 10 cos 1x. First is we must find the value of b or the period, where the formula of period equals 2 pi over b. And since the value of b on the given equation is 1, so the period is 1. Period equals 2 pi over b is to period equals 2 pi over 1 is equals to 2 pi. The 2 pi will be the value of the end of the cycle. As the given equation is y equals 10 cos 1x, the value of amplitude will be positive 10, and the given function is on the cosine function graph, means it will start at the y-axis of positive 10. So since the value of the end of the cycle is 2 pi, the half value of 2 pi is 1 pi or pi, then half between of 2 pi and pi is 1.5 pi or 3 pi over 2, and the half value between the origin and 1 pi is 0.5 pi or 1 pi over 2. As a result, the graph will look like this. So the next topic will be the other types of sine and cosine graph by Denise Carabbacan.
Let us now proceed to the third subtopic, graphs of y is equal to a sine b times to the quantity of x minus c plus d, and y is equal to a cos b times to the quantity of x minus c plus d. In trigonometry, a sine wave, also known as a sinusoid, is the graph of the sine and cosine function. Other areas of study, such as science and engineering, use sinusoidal functions. This function may also be found in nature, such as ocean waves, sound waves, and light waves. In addition, this function is similar to the average daily temperatures for each day of the year. Stuart Kenny, a Scotsman, coined the word sinusoid in 1789 while observing the development and harvest of soybeans. The general equation of the sinusoidal function is y is equal to a sine b times to the quantity of x minus c plus d, whereas a is the amplitude and must always be absolute, b is the cycles from 0 to 2 pi, or also known as the frequency. B is also used to compute the period with the formula 2 pi over b. D is the vertical shift or the displacement, and lastly, C is the horizontal shift or also called the phase shift. Because the cosine function is similar to the sine function, except for a horizontal shift to the left of 90 degrees or pi over 2 in radians, the general form of the cosine function can also be y is equal to a sine b times to the quantity of x minus c plus d. Any cosine function can be written as a sine function. The picture on the left is an example figure on what a sinusoid looks like with the corresponding parts. Note that in this topic, we are using radians, not degrees, and there are 2 pi radians in a full rotation. Refer to the pic on the right. In the previous subtopic, Frank already discussed some parts of the graph, which is the amplitude and the period. For this topic, there are 2 parts added, and these are the phase shift and the vertical shift. The phase shift is how far the function is shifted horizontally from the usual position, while the vertical shift is how far the function is shifted vertically from the usual position. Basically, phase shift is either it shifts to the left or to the right, and vertical shift is either upward or downward. The phase shift is positive if it is to the left, and negative if it is to the right. Let us now try and solve some examples.
amplitude natin. base na lang din kayo sa unit circle. Unit circle of radians. Una natin gagawin, i-determine yung sinusoidal axis. At para ma-determine natin yung sinusoidal axis, malalaman natin ito sa value ng vertical shift. Dahil ang value ng vertical shift ay 3, nasa 3 ang sinusoidal axis. So, ang midline, pagdalaan ng range, ng divided by 1/2 is equal to 4 pi. Ayan, 4 pi. Bakit naging 4 pi? I-multiply mo lang yung 2 pi sa resiprocal ng denominator. Since ang denominator ay 1/2, ang reciprocal ng 1/2 ay 2 over 1 pi. So, 2 pi times 2 is equal to 4 pi. Bago tayo mag-graph, paano natin malalaman yung starting point ng graph? So, since ang phase shift natin ay pi, at ang pi ay positive, meaning magsisimula tayo dito to the left.
For the next topic, we have here the graphs of secant and cosecant functions. Secant function was defined by the reciprocal identity of cosine. Notice that the function is undefined
your entire life flashes in front of your eyes the second
leading to vertical asymptotes pi over 2, 3 pi over
First of
2.
all, that 1
Because the
second
cosine is
isn't a
now more
second
than
at
1
all.
in absolute value,
It stretches on forever,
reciprocal
like
never
the
less
motion
than
of
1
time.
in absolute value. When the cosine function is 0, the secant is undefined. We can graph secant function by observing the graph of cosine function because these two functions are reciprocals of one another. As we can see, the graph of the cosine is shown as a dashed orange wave, so we can see the relationship where the graph of cosine function decreases and the graph of the secant function increases. When the graph of cosine function increases, the graph of the secant function decreases. The secant graph has vertical asymptotes at each value of x where the cosine graph crosses the x-axis because the inverse of 0 is undefined. Similar to the secant, the cosecant function is defined by the reciprocal identity of sine. The function is undefined when the sine is 0, leading to a vertical asymptote in the graph at 0, pi, and etc. Since the sine is never more than 1 in absolute value, the cosecant, being the reciprocal, will never be less than 1 in absolute value. The cosecant graph has vertical asymptotes at each value of x where the sine graph crosses the x-axis. We show this in the graph below with dashed vertical lines. Note that since sine is an odd function, the cosecant function is also an odd function. Features of the graph of secant function. The stretching factor is a. The period is 2 pi over b. The domain is x and equal to pi over 2 absolute value of b, k, where k is an odd integer. Range is negative infinite, negative absolute value of a, yet the positive value of a, positive infinite. And x is equal to pi over 2 absolute value For the second example, as I've said earlier, cosecant function is the reciprocal identity of sine. The next thing we have here is our given, which is a is absolute value of negative 3 is equals to 3. Then b is equal to 4. And lastly, our period is equal to 2 pi over b, which is 2 pi over 4 is equal to pi half. So the important thing we have here is x scale or 4 points. And in order to get the x scale, we need to divide our period to 4, which is pi half divided by 4 is equal to pi 8. Then now let's proceed in making the graph. Now we're going to draw the points which will serve as our pattern in making the sine graph. In completing a sine graph, I will be sketching a dashed line to connect the dots. So this sine graph will serve as our guide in completing our graph. In this graph, cosecant pi over 4 is equal to 1 over 0. Since the value of x is equal to 0, the value of y is also 0. So therefore, in the cosecant graph, in every x-axis, we have the asymptotes. To let you know, the blue dashed line represents the asymptotes of this graph. And now, to finish the graph, all we gonna do is to take the max and the min. So this is how the graph looks like. Graphing variations for secant and cosecant functions. We find the vertical asymptotes and evaluate the functions at a few points for shifted, compressed, and stretched versions of the secant and cosecant functions, specifically the local extrema, any point at which the value of function is at largest or smallest. If we simply want to graph a single period, we may set the interval for the period in more than one, because the function identity indicates the secant graph is the same as the cosecant graph. Move half a period to the left. The process of for secant is fairly similar. Vertical and phase shifts can be applied to the cosecant functions in the same manner as they can do secant and other functions. The resulting equations are so follows. Features of the graphing variations of secant function. The stretching factor is a. The period is 2 pi over b. The domain is x m equal to c over
equal to pi over 2. P is equal to 2 pi over p, which is 2 pi over pi half. Now to completely get the period, we have here 2 pi over 1 times 2 over pi is equal to 4. Now we have here our phase shift, which is 0 over pi divided by 2 is equals to 0. Now let's construct our graph. Constructing the graph, we carefully sketch points, the domain which is our maximum value. Make sure that our domain, which is 1, is compared to our maximum, which is 25 also. This is how the graph looks like. Next, we have here the graph of cotangent and tangent.
Graph of tangent functions. Tangent x is equal to sine x over cosine x. Consider the denominator of this fraction. For some values of x, the function cosine x has value of 0. For example, when x is equal to pi over 2, the value of cosine pi over 2 is 0. And when x is equal to 3 pi over 2, we have cosine 3 pi over 2 is equal to 0. When this happens, we have d in the fraction's denominator, which indicates the fractions is undefined. As a result, the functions will have a gap at the moment. This gap is known as discontinuity. For other values of x, the same thing happens with cotangent x, secant x, and hypotenuse. For each one, the denominator will be 0 for specific x values. In tangent functions, y is equal to tangents times px. There are two vertical asymptotes that you need to remember. These are the pi is over 2 and negative pi over 2. In sine and cosine, the period is 2 pi over b, but the tangent and cotangent, the period is equals to pi over b. For example, graph the tangent functions of y is equal to tan times 1x in a 1 period. The given is a is equal to pi over 2 and negative pi over 2. And b is equal to 1. And the period is pi over b is equal to pi over 1 is equal to pi. And it is an increasing tangent functions, which the graph will look like this. For example, graph the tangent functions of y is equal to tan times 1x in 2 periods. The given is a is equal to pi over 2 and negative pi over 2, and the b is equal to 1. The period is pi over b is equal to pi over 1 is equal to pi, and it is increasing tangent functions, which the graph will look like this. The range is negative, infinite, and infinite. The domain is x unequal n pi over 2, where n is equal to positive to negative 1, 3, 5, and so on. Let's argue the tangent curve by stretching and shrinking in vertical and horizontal. The tangent functions such as sine and cosine functions may be expressed by numeric functions. Y is equal to a tan times bx. Using a and b values, we will determine horizontal and vertical stretches and comparisons. The horizontal stretch features of the graph of y is equal to a tan times bx. The stretching factor is absolute value of a. The period is p is equal to pi absolute value of b. The domain is all real numbers x, where x inequal pi over 2 absolute value of b plus pi over absolute value of b, and k, such that k is an integer. The range is negative infinite and infinite. To find a pair of asymptotes, solve the equations px is equal to negative pi over 2 and px is equal to pi over 2. To find other asymptotes, from those choose the period of the functions. Y is equal to a tan times bx is an odd functions.
For our first example, all we have here is our p, which is 1/2. So let's proceed in finding the period. So in finding the period, we have here our pi divided by b, which is pi divided by 1/2. So pi divided by 1/2 is equal to 2. So this means our period here is 2 pi. So we're going to find next our x scale, which is 2 pi divided by 2 is equal to pi. Let's proceed in sketching our graph. So our first interval here is pi, and this is the spot where we going to place the asymptote, and followed by 2 pi. So after sketching our asymptote, we're going to sketch next our tan graph. So our graph looks like this.
A tangent graph is a continuous graph that is not defined or traceable in such a graph. The values of the sine term is equal to 0. The cotangent is defined with reciprocal and multiplied cotangent x is equal to 1 over tangent x, with the vertical asymptote of the tangent x is equal to 0, pi over 2, negative pi over 2, 3 pi over 2, negative 3 pi over 2, so on. But no cotangent, and for cotangent functions, it will be 0, pi, negative pi, 2 pi, and negative 2 pi, and so on. We can graph y is equal to tangent x when observing the graph of the tangent functions, because these two functions are reciprocals for one another. Where the graph of the tangent function decreases, the graph is cotangent function increases. Where the graph of the tangent function increases, the graph of the cotangent function decreases. The cotangent graph has vertical asymptotes at each value of x where tangent x is equal to 0. We show this in the graph below, which does since the cotangent is reciprocal of the tangent, cotangent x has vertical asymptotes at all values of x where tangent x is equal to 0 and cotangent x is equal to 0. At all values of x, cotangent x has its vertical asymptotes. Graph of cotangent functions. The standard equations for cotangent functions is y is equal to a cotangent times bx, where the stretching factor is absolute value of a. The period is p is equal to pi absolute value of b. The domain is x inequal pi over absolute value of b and k, where k is an integer. The range is negative infinite and infinite. The asymptotes occur at x is equal to pi over absolute value of b, k, where the k is an integer. Y is equal to a cotangent bx is an odd functions.
Now we have here our second example, which is a is equal to 3 and period is equal to pi over 4. Now let's sketch our graph. So we'll be placing our asymptotes on pi over 4. Now I will be sketching first our tan graph to serve as our guide in sketching cotangent graph. Now I will be sketching our cotangent graph. So this is how our graph looks like.
You must remember this rule, for this is the guide in graphing a tangent and cotangent functions, whether it is positive or negative tangent and cotangent. Equation of Simple Harmonic Motions, or SHM, by Elvilyn Garcia. Periodic motion is usually modeled by either sine or cosine functions, and that's called the simple harmonic motions. The displacements y, direct, height or length of an object behaving in simple harmonic motions with respect to time t is given by one of the following. Y is equal to a sine b times t minus c plus d, or y is equal to a cosine b times multiplied by t minus c plus d. To determine the appropriate values of a, b, c, and d, we can assume that the a and b are positive numbers and c is the smallest such non-negative numbers. Parts or features of simple harmonic motions. The first one is amplitude. Absolute A is equal to 1/2 capital M minus M, the maximum displacement above the and below the rest of positions, where capital M is the maximum height and M is the minimum height. Second one is period. 2 pi over absolute of B, the time required to complete one cycle. Form one highest or lowest point to the next. The third one is frequency. Absolute B over 2 pi, the number of cycles per unit of time. The fourth one is C, responsible for the horizontal shift in time. And the last one is D, responsible for the vertical horizontal shift in displacement. So D is equal to A plus M. Displacement y is direct height of an object behaving in simple harmonic motions. The time is given by one of the following equations. The first one is y is equal to a sine b times t minus c plus d, or y is equal to a cosine b times t minus c plus d. Both the following of the equation of simple harmonic motions. To determine the appropriate values of A, B, C, and D, we can assume that the A and B are positive numbers and C is the smallest such non-negative number.
So this is our example number 1. So a weight is suspended from a spring and is moving up and down in a simple harmonic motion. At the start, the weight is pushed by 5 cm above the resting positions and then release. After 8 seconds, the weight reaches again to its highest. Find the equation of the motions and locate the weight with respect to the resting positions after 15 seconds since was released. So this problem asks for a circular functions. So what is circular functions? It's applicable to those with simple harmonic motions. So in this problem, first thing we need to do is to understand the problem. And because if we do not understand the problem, we cannot answer it. Okay? Next is, as much as possible, it would be easier if you're going to illustrate the problem. So this problem is, a weight is suspended at the end of the spring. So let's draw a spring. And then the end of the spring. So the spring goes up and down, so goes up and down. So if we do the spring, it will be proof it would be make a simple harmonic motions, right? So it goes up and down, and if we're going to graph the in respect to the time and to the distance, this is trouble in respected to the some positions. So like this. Okay. It wants to make simple harmonic motions. The graph would be look like a sine or a cosine, just like this. Just like this. Yeah. And so the weight is pushed by the 5 centimeter, pushed by 5 centimeter above the resting positions. Above the resting positions. Yeah. So by the way, this is resting positions that wherein you did not move the spring, or you did not put the force apply force of it, so that it resting positions. So if you going represent the as a 0 in a terms of y is the distance of if go up, so that distance, and this would be for the time. Okay, to make the spring wave, what he did is he pushed the spring up 5 centimeter 5 centimeter and 5 centimeter. He released it after spring move up and down. So after 8 seconds, the weight reaches again, so its highest positions. So the highest positions, it could reach at 5 centimeter. So if after 8 seconds, so this is the time. So 1, 2, 3, 4, 5, 6, 7, 8. So he reached again the highest positions after 8 seconds. So this is 8, 2, 4, 6, 2 per 6, 8. So yeah. So if we graph this would be after 8 seconds. So dito natin ilalagay kasi nga after seconds, di ba? Magiging ganyan yung itsura niya. So this is the illustration of the graph of the motions of spring with motions of the weight, the motions in the springs. So next is we're going to find the equations of the motions and locate the weight with respect to the resting positions after 45 seconds since it was released. So, as you can see here, dinrawing ko na yung yung cosine and sine. So, this is the graph of, you can see, is more other less sine or cosine functions, the graph of sine and cosine functions. So, if we're going to compare that, the graph of cosine and sine would be mas magiging mapadali siya. So, ang gagawin natin is i-compare natin sila kung saan ba sila magkatulad para mas magiging mapadali yung pag-formula natin. Magkatulad po kasi si cosine at si mas malapit sila sa isa't isa. So, the formula of cosine. So, ito yung pinili natin cosine kasi magkaparehas sila. 'Di ba? Kaysa dito sa sine. So, the formula of cosine is y is equal to amplitude cosine b times t minus c plus d. So, this is our formula. So ano yung A natin? A is equal to 5. Bakit 5? Kasi nga, di ba ito yung resting positions natin? So, ang amplitude kasi kung gaano siya kataas. So, 5 cm dito, di ba, right? So, magiging, the amplitude is 5. So, going to solve the B is equal to, the B, yung B kasi kapag sinolve natin, magiging 2 pi absolute of B, di ba? B. Kasi kapag hinanap kasi natin yung period niya, kung gaano siya, kung ano yung time niya, di ba? Kung ano yung time niya. So, yeah. Kung gaano yung katagal niya. So, it's 8 seconds. So, ang susunod dyan is, the second is B times 8 is equal to 8B divided by both side 8. So, cancel. So, magiging 2 pi over 8, or in the simple form, magiging pi over 4. So, the B is, yung B natin is magiging pi over 4. So, next we're going to solve the C and D. So, as you can see here, the C is, wala siyang movement. Pa-horizontal siya. And, yung D din, same sila. So, wala silang movement. Yung D kasi walang movement up the upward or downward, so magiging 0 siya. So, this formula simplify to y is equal to a cosine bt. So, we're going to substitute. So, magiging y is equal to, yung a natin is 5, and then cosine by, yung b natin is pi over 4 times t. So, this is the answer. So, next, we're going to solve now the resting positions of the weight, reduce back to the positions of the 45 seconds. So, magiging formula niya is t is equal to 45, right? And then, so magiging y is equal to 5 cosine pi over 4 times pi 45. So y is equal to 5 cosine. So yung cosine natin is substitute by 180. So ang magiging,
So, kapag nag-solve tayo, ito muna yung uunahin natin para hindi tayo maguluhan. So, magiging 180 times 45 is equal to 8,100 divided by 4 is equal to 2,025. So, 5 cosine to 2025. So, kapag nakuha nyo na to, itong 2025, and magiging ano siya, wait lang, 2025. I-direct nyo siya, direct by, multiply by 5 is equal to negative 3.5355. So, ito yung magiging answer niya. So, kapag nakuha na natin yung sagot niya, ang ibig sabihin niyan is at 45, andito siya sa baba. So, magiging negative 3.53. So, yun. Thank you for listening to me for my explanations.
These are our definition of terms. And that is all for our video lesson. Thank you for watching.